Welcome to Math Made Easy. You know, sometimes in history, you stumble across these little coincidences that just make you stop and think. Today, we're diving into one of those, a single, ordinary day that has an extraordinary connection to some of the greatest minds in science.
So, let's start with a little riddle. What on earth could possibly link a trailblazing female astronomer from the 1700s with a modern mathematician who won the biggest prize in his field? I mean, they're from completely different centuries, working on totally different problems. What's the thread that ties them together? Believe it or not, the answer is just a date. All of these brilliant people and a few more we're about to meet are all connected by one day, March 16th. It's almost like this day has some kind of weird gravitational pull on the history of science. All right, so to really get to the bottom of this, let's start at the beginning. We're going to look at the incredible people who were born on this very special day. Our journey kicks off way back in 1750 with the birth of Caroline Herschel in Germany. Now, her family thought her future was pretty much set, taking care of the house. But Caroline, her curiosity was way too big to be kept indoors.
And that curiosity took her to some amazing places. She moved to England to help her brother William, but she wasn't just an assistant for long. Get this, she discovered 8 comets on her own, became the first woman in England to get a royal salary for her scientific work, and the first to snag the gold medal from the Royal Astronomical Society. Her catalog of nebulae, it became a go-to resource for astronomers for years.
All right, let's jump forward a few decades. The year is 1789, and on March 16th, another German science giant is born, Georg Simon Ohm.
If you've ever taken a basic physics or electronics class, you definitely know that name. Ohm's law is one of those bedrock principles of science, perfectly describing how voltage, current, and resistance all relate to each other. And don't let its simplicity fool you. This little equation is an absolute cornerstone of all modern technology.
Now, let's switch gears a bit and head into the more abstract world of pure math. On March 16th, 1821, Eduard Heine was born. This was a guy who loved digging into the very foundations of calculus, the really deep questions about things like limits and continuity. And Heine's work was seriously fundamental. He came up with this idea of uniform continuity, which sounds a bit technical, but it's a super important concept for proving big theorems in math. And the Heine-Borel theorem? Yep, that's still a classic that every math major has to learn today. Okay, let's leap into the 20th century for our next March 16th birthday. This is Kunihiko Kodaira, a brilliant Japanese mathematician who would go on to totally reshape modern geometry. And 1954, wow, what a year for him. That was the year Kodaira was awarded the Fields Medal, which is basically the Nobel Prize for mathematics. He got it for his game-changing work in algebraic geometry and complex manifolds, stuff that really pushed the boundaries of what we thought was possible in math. But the story of March 16th isn't just about birthdays. It turns out this same date also marks the end of the line for an equally impressive group of scientific thinkers.
On March 16th, 1838, America lost a true original, a self-taught mathematician named Nathaniel Bowditch. This guy's formal schooling stopped when he was 10. But he just kept reading and teaching himself, eventually becoming a master of celestial navigation.
And Bowditch didn't just learn things, he made them better. He found literally thousands of errors in the #1 navigation guide of his time, so he wrote his own, which sailors started calling the Sailor's Bible. But his biggest project was translating Laplace's super complex celestial mechanics into English, adding his own notes to make it understandable. Just an incredible feat. Now, this is kind of wild. Exactly 3 years after Bowditch passed away, on March 16th, 1841, the French physicist Félix Savart died. He was actually a doctor by trade, but his real passion, his obsession, was physics. And that passion left a huge mark. Working with his partner, Jean-Baptiste Biot, he came up with the Biot-Savart law. This is another one of those powerhouse equations. It's essential for figuring out the magnetic field that an electric current creates. It's a pillar of electromagnetism. And the coincidences just keep piling up. 2 of the greatest educators and historians of math also died on March 16th. In 1922, we lost Georg Halsted, the guy who first brought non-Euclidean geometry to the US. Then, in 1940, Sir Thomas Heath passed away. His translation of Euclid's Elements is still the gold standard today. Okay, our final departure is the Hungarian mathematician Alfréd Haar, who died on March 16, 1933. He was a brilliant analyst who came up with something truly special, something people thought couldn't even be done. He developed what we now call the Haar measure. It's a super powerful tool for defining volume in really abstract mathematical spaces. Now, the funny part is, the legendary John von Neumann, one of the smartest people who ever lived, told Haar not to even bother trying because he thought it was impossible.
Well, Haar went and did it anyway, and his success led to this fantastic little limerick that people still share today. It goes, "Said a mathematician named Haar, von Neumann can't see very far. He missed a great treasure, they call it Haar measure. Poor Johnny's just not up to par." It's just a great little peek into the human side of science, right?
So let's take a step back and just absorb all of this. We've got births and deaths stretching across centuries, from Germany to America to Japan, all centered on this one day on the calendar. I mean, when you lay it all out like this, the sheer scale of the coincidence is just undeniable. You've got astronomy, physics, pure math, the history of math. The amount of brain power connected to March 16th is just off the charts. It's one single day that truly helped build our modern understanding of the universe.
It really makes you wonder, doesn't it? Is this all just a random quirk of statistics? You know, our pattern-seeking human brains trying to find meaning where there isn't any? Or is there maybe something more going on here? Some kind of hidden rhythm or pulse to the history of science? In the end, whether it's just pure chance or something else entirely, the story of March 16th is just a fantastic reminder that history is filled with these amazing hidden connections. It makes you want to look a little closer at the dates and names and just ask, what other incredible patterns are out there waiting for us to find them? Please like, subscribe Math Made Easy channel.